Hello? 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 Is mic working? Hello? Mic test? Hello? Yes. Hello students, welcome everyone to the next session of the topic integration. We have already covered what is integration, definition of integration, some standard integral functions and formulas, and then we have also solved what is integration by substitution method and how to make some substitutions, standard substitutions. What are the different types of substitutions we have? Direct substitution, indirect substitutions, and some standard substitutions. We have discussed some problems regarding to how to make substitutions when certain types of functions are available. Okay, now we will continue with the next topic. We will again learn some more formulas for the integrals. Okay. In the last class, we have discussed some problems related to substitution method of integration, and now we will again learn some more formulas for integration. Some integrals of some standard functions. 1 by root of a square minus x square. We have already learned what is integral of dx by root of 1 minus x square, that is sin inverse x. Here, if there is a square minus x square, then we have sin inverse x by a. Now, how do we get this formula? First, what we need to do is substitute x equal to, we make some substitution where x is equal to a sin theta. X is equal to a sin theta. If we make this substitution, then we will have this value inside the square root as a square minus x square will become a square minus a square sin square theta, a square sin square theta. A square is common, so we can take a square outside and we will have 1 minus sin square theta. And what is 1 minus sin square theta? Cos square theta. So we will get a square cos square theta. So this value integral will become, integral of dx will be a cos theta d theta. Now integral will become, integral of dx will be a cos theta d theta divided by square root of a square minus x square, that will be a cos theta, a cos theta. So a cos theta will get cancelled and we will have integral of d theta, integral of d theta. And what is integral d theta? Theta plus c, where c is the constant of integration. What is our requirement? Again, we need to write theta in terms of x. So what is theta from this? X by a is equal to sin theta. Sin inverse of x by a will be theta. So this is nothing but sin inverse of x by a plus constant of integration. This is how we obtain this formula. Is it clear, students? What is the procedure? Make the substitution x equal to a sin theta. So whenever we encounter terms like this, a square minus x square, make the substitution a sin theta or a cos theta. Both will be okay. Similarly, when you have plus, then make the substitution a tan theta. We will get this answer automatically. So these are the standard substitutions which we will make so that this integral will become into standard form. Right? Okay. Next is integral of 1 by dx by square root of a square plus x square. Now what is the substitution we should make? A tan theta. Then we will get this answer. We can solve this by substituting x equal to a tan theta. You can take that as homework. Remaining can be done by yourself. It is very easy. Again x square minus a square. then what is the substitution we should make? Our purpose is to eliminate this square root and convert into simpler forms. So here when we have a tan theta, then a will be common. We have 1 plus tan square theta, that will become secant square theta. When you take square root, it will become secant theta, a secant theta. And the numerator will have a secant square theta, as tan theta differentiation is secant square. Here we will have, we can make the substitution secant square, a secant theta as x. So we will get a square secant square theta minus a square. If we take a square common, we will get secant square minus 1, that will become tan square. So our purpose of making substitution is to simplify this, reduce this integrand into simpler form, that will be easy to integrate. So its answer will become log of x plus root of x square minus a square. The easy way to remember this formula is, here we have x square coefficient as positive for both, and we have square root of x square term plus or minus some constant. Square root of x square is x, and this is of the form dx by x. Integral dx by x will start with log x. Formula is log x. So what we need? Answer will become log of some value, and that value is nothing but x plus, right, whatever is there in the denominator. Similarly for this, x plus root of x square minus a square. That is the formula for this integrand. So what we need to find? Integral of dx by square root of a square plus x square means, here we have coefficient of x square is positive. This is square root of x square is x. So that means dx by x form. So answer will be log x. Log of x plus, write the value here. Same for this. Log of x plus, write the value here. Right, students? Next, fourth formula, dx by a square plus x square. Again we can make the same substitution. Substitute x equal to a tan theta. Whenever we get this term a square plus x square, use the substitution a tan theta. Again we will have the same result. So here answer will be 1 by a tan inverse x by a plus c. You can try these substitutions yourself. Answer, it is very easy to solve. You can derive this, prove this properties by yourself. So here dx by a square plus x square will be equal to 1 by a tan inverse x by a plus c. Until now we have discussed 4 formulas. What are they? One is dx by root of a square minus x square, sin inverse x by a, 1 by root of y square plus x square, that will be log of x plus root of. Similarly, x square minus a square means log of x plus root of whatever is inside the root, write as it is. Dx by a square plus x square, 1 by a tan inverse x by a. Next formula is dx by a square minus x square and dx by x square minus a square. Answer is 1 by 2a log of x minus a by x plus a. We can prove this. This proof will be similar to that. Okay, how to prove this? First is, we can write x square minus a square as x plus a into x minus a, x plus a into x minus a. Now this integral is integral of dx by x minus a into x plus a. We are trying to prove for this. Proof. Dx by x square minus a square is x minus a into x plus a. And what we need to do is try to bring this denominator part, these factors, into numerator. We can write x plus a minus of x minus a. This is equal to x plus a minus of x minus a divided by x minus a into x plus a. X minus a into x plus a. Okay, now if we subtract these two, x will get cancelled. A minus of minus a is plus a, so it will be 2a. We have to divide this value by 2a. 2a into dx, integral dx. Okay, now what we got? 1 by 2 is constant, we can take it outside. This is equal to 1 by 2a integral of, now we can divide this separately, that will be x plus a will get cancelled from the first term, we will get 1 by x minus a minus of 1 by x plus a, 1 by x plus a dx. Now what is the integral of 1 by x? Log x, where coefficient of x is 1, so we will divide by 1. So what is the answer? It will be 1 by 2a of log mod x minus a minus log mod x plus a plus constant. So what is the answer, students? This is equal to 1 by 2a of log of, ln means log, log. So log of modulus log a minus log b, log a by b. So this will be log modulus x minus a by x plus a plus constant. This will be the result for this formula. So integral dx by x square minus a square is 1 by 2a log of modulus x minus a by x plus a. Now what is the proof for fifth one? It is same formula. Here when we take minus outside, we will get this term. That means answer will be minus of this. When you take minus in front of log, that means these two will become reciprocal of each other. Then we will get x minus a will be in denominator, x plus a will be in numerator. So x plus a by x minus a, where as we are taking modulus, a minus x and x minus a modulus is actually same. So that's how we get this formula. Right now. So this is the proof for fifth and sixth property. Next one. Square root of a square minus x square. Again we have to make the substitution x equal to a sin theta and derive this. Another way to solve this problem is to use integration by parts. We have many methods to derive formulas, find values of integral. Whichever is suitable, whichever is easier to solve, we can use that. Here, integral of square root of a square minus x square dx. Formula is write x by 2 into square root, this part as it is, plus a square by 2. Remember this formula. X by 2, write the value as it is, plus a square by 2 into, if this is in denominator, what is the formula? Write that here. What is the formula for square 1 by square root of? This will be sin inverse x by a. So what is the formula we get? Here square root of a square minus x square will be x by 2, write this part as it is, plus a square by 2 sin inverse of x by a. Where sin inverse x by a, when this term is in denominator, you will get that, so write that. Same condition applies for the remaining formulas also. So here square root of a square plus x square means x by 2 into, write this as it is, plus a square by 2 into whatever is there. If it is in denominator, what is the formula? It will be like 1 by x term. So answer will be log x plus root of this value. Log x plus root of a square plus x square plus c. Similarly, x square minus a square, square root. X by 2 into, write as it is. Then minus of a square by 2. Here whichever is the coefficient, write that. X square minus a square means write this minus a square by 2. This is a very, very critical part. This minus is very, very important. Right up. So this only this change will be there in this formula. Other formulas will be same. So here everything will be plus. In this formula alone we get minus. When there is minus a square here. So remember it like this. Minus a square by 2 into log of this value. If it is in denominator, what is the formula? Write as it is. So this is the form. These are the formulas for different types of integrals. These will be useful for solving many problems henceforth. So question is, find the integral of dx by 4 minus x square, square root of 4 minus x square. Now how to solve this? It is of the form, first we have to identify in what form this question is given. It is of the form dx by square root of 4 minus x square. And what is the formula for that? Dx by square root of 4 minus x square is, this will be equal to This is of the form dx by a square minus x square, where a will be 2. So what is the formula? Dx by root of a square minus x square is sin inverse x by a, direct formula. So this will be sin inverse x by 2, direct application. So we can write this directly. This will be 2 square minus x square. What is the formula? Dx by square root of a square minus x square is sin inverse of x by a. A is this part. So here we will get sin inverse x by 2. So answer is sin inverse x by 2 plus constant. Next is integral of dx by 1 plus 4x square. Okay sir, now how to solve this? Dx by square root of 1 plus 4x square. Now what we need to do is make this coefficient of x square as 1. Always keep that in mind. First what we need to do then, take this 4 outside. Then we can write this as 1 by 4 integral of dx by, this term will be divided by 4, 1 by 4, that is 1 by 2 square plus x square. Now this is the result. First we will write this in the standard form. This is of the form dx by x square plus a square. What is the formula, students? Dx by x square plus a square is 1 by a tan inverse x by a. So this is equal to 1 by 4 into 1 by a is 1 by 2, 1 by a tan inverse of x by a, x by 1 by 2 plus constant. Now what will be the answer? This 2 will go to the numerator, so these 2 will get cancelled out. 2, we will get 1 by 2 tan inverse of, this 2 will go to the numerator again, so we will get 2x plus constant. Clear now? So this is how we should solve this. So what is the solution? Dx by 4x square plus 1 means, first take 4 outside, 1 by 4 dx by x square plus 1 by 2 whole square. Now formula is dx by x square plus a square. Formula is 1 by a tan inverse x by a. We just need to remember the formula. Try to write this given expression in standard form and use the formula. That's it. Next question is dx by x square minus 81. 81 is nothing but 9 square. So this is of the form dx by x square minus a square. What is the formula? 1 by 2a log mod x minus a by x plus a. So we will directly write, what is the formula? 1 by 2a, a is 9, a is 9. That means we will get 1 by 2a, integral value will become 1 by 2a, 2a is 18, log of modulus x minus a by x plus a, that is x minus 9 by x plus 9. Easy question, plus constant of integration. How do we write that? Just use the formula. What is the formula? Dx by x square minus a square means integral will become 1 by 2a log modulus x minus a by x plus a plus constant of integration. So direct formula 1 by 2a log mod x minus a by x plus a, that is x minus 9 by x plus 9. 2a is 18. So 1 by 18 log this value. Easy questions. Another question, integral square root of, this form is like a square minus x square. What is the first step, students? Make this coefficient of x square is 1. That means we have to take 25 outside. Then we will get, if we take 25 outside, square root of 25 will become 5 into integral of square root of 16 by 25 is 4 by 5 whole square 4 by 5 whole square minus x square minus x square. Okay, now what we will get? This is equal to dx. Now this is of the form square root of a square minus x square. What is the formula? 5 into x by 2 square root of whichever is given there, that is 4 by 5 square minus x square plus a square by 2, where a square is 16 by 25. So 16 by 25 into 2 is 16 by 50. Sin inverse of x by a, x by 4 by 5 plus constant of integration. Now simplify. This is equal to 5 into x by 2. Here this will be square root of 16 minus 25 x square divided by 5 plus 16 by 50 is 8 by 25 sin inverse of 5x by 4 plus constant of integration. Now these 5 will get cancelled. Here we will get divided by 5. So this 5 will get cancelled. Here we will get 5. So answer is x by 2 square root of 16 minus 25 x square plus 8 by 5 sin inverse 5x by 4 plus constant of integration. So first take 5 outside and then convert it to standard form. What is the standard form? Square root of a square minus x square. We already know the formula for that. What is the formula? X by 2 square root of this plus a square by 2 sin inverse x by a. So here 5 into x by 2, write this as it is, plus a square by 2, that is 16 by 50 sin inverse of x by a, that is x by 4 by 5 is 5x by 4. So now simplify this. So answer comes out to be x by 2 square root of given question plus a square by 2 will become 8 by 5 sin inverse of 5x by 4. Easy questions. We just need to convert this given question in standard form and apply the formula. Next is another interesting question. Here we have 1 by dx by x square plus x plus 1. Now this is not in standard form. It is not in perfect square form also. But if we have a linear term x plus some number or 2x plus 1 whole square, then we can treat that number as some x square, because we have already learned in substitution method of integration. We can assume linear function of x as x itself and integrate, but then finally divide the value by coefficient of x. So here what we can do is try to write this in terms of linear term of x first, some x square term. So we need to remove this, eliminate this x term. Now how to do that? There is a common way to do that. This x square plus x plus 1 can be written as x square plus x plus 1 can be written as. Remember it, it will be very helpful in many applications, many problem solving. You will also learnt in quadratic equation how to factorize, how to make a perfect square number out of given quadratic expression. What we need to do? Write this coefficient x square term, write as x. If there is plus sign here, write plus. If there is minus sign here, write the minus sign of coefficient of x, and then whichever is the coefficient of x divided by 2. So this will be x plus, here coefficient of x is 1, so we will divide that by 2, that is 1 by 2. Write this square. Now what will we get when we expand this? We will get x square plus, this will be 2 times x into 1 by 2, that will be x. So that is why we are dividing, as the formula is a plus b whole square is a square plus b square plus 2ab. So we have to divide this number by 2 and then square. Then we will get x square plus x. Remaining what we will get? Plus 1 by 4. So we have to subtract 1 by 4. This will be plus 1, right, as it is, minus, we have to subtract this 1 by 4. That will be equal to x plus 1 by 2 whole square. 1 minus 1 by 4 is 3 by 4. 3 by 4 is root 3 by 2 whole square. Root 3 by 2 whole square. So we will get this x square plus x plus 1 will be equal to x plus 1 by 2 whole square plus root 3 by 2 whole square. So this value becomes, integral becomes I is equal to integral of dx by x plus 1 by 2 whole square, x plus 1 by 2 whole square plus root 3 by 2 whole square plus root 3 by 2 whole square. Okay. Now this is of the form dx by x square plus a square. So what is the formula? 1 by a tan inverse x by a. So this will be equal to 1 by a is root 3 by 2. 1 by a tan inverse of x by a. What is x? Here in place of x we have x plus 1 by 2. So write x plus 1 by 2, x plus 1 by 2, x by a. A is root 3 by 2. Root 3 by 2 plus c. Plus c. Now this is equal to 2 by root 3 tan inverse of, here we will get 2 to the numerator, so we will get 2x plus 1 divided by root 3 plus constant of integration plus c. So answer, final answer will be 2 by root 3 tan inverse 2x plus 1 by root 3 plus c. So this is how we should solve this question, students. Clear now how to solve? What is the first step? Try to factorize this. Try to write this in terms of perfect square. That will be x plus 1 by 2 whole square plus root 3 by 2 whole square. Then this is of the form dx by x square plus a square. So use the appropriate formula for that. That is it. Okay. Now we will see the solution for this. So try to write this in terms of perfect square. That will be x plus 1 by 2 whole square plus root 3 by 2 whole square. Now what is the formula for dx by x square plus a square? 1 by a tan inverse x by a. So answer will be 2 by root 3 tan inverse of 2x plus 1 by root 3 plus constant of integration. Next question is square root of, integral square root of 3 plus 8x minus 3x square. Now what is the condition? First step is to make this coefficient of x square as positive 1. Try to write it like that. Then there won't be any mistake. What we will do is, first I will try to write this term alone. First I will write this 3 plus 8x minus 3x square as, we can take minus 3 outside, minus 3 into, we will get x square, then we will get minus 8 by 3 of x, minus 8 by 3 of x, minus 3. Is that clear, students? We are taking, minus 8 by 3 minus 1. Minus 1. We are taking minus 3 outside. So it will be plus 3 plus 8x minus 3x square. Right. Now what we need to do? Minus 3 times of. Now write this in terms of perfect square. This quadratic in terms of perfect square. That will be x minus, this will be 8 by 3 divided by 2, that is 4 by 3, x minus 4 by 3 whole square. Here we already have minus 1, minus of, this will be plus b square will be 16 by 9, so we have to subtract 16 by 9. Then we will get minus 3 into x minus 4 by 3 whole square, x minus 4 by 3 whole square, 9 minus 16, that will be minus 25 by 9. This will be 5 by 3 whole square. So this term is actually 5 by 3 whole square. Okay. Now what we get from this? This integral will become I is equal to integral of here minus 3, so we can take root 3 outside, square root of multiply by minus. Then we will get 5 by 3 whole square minus of x minus 4 by 3 whole square, x minus 4 by 3 whole square dx. Okay, now this is equal to root 3 into, what is the form of this? It is in the form of a square minus x square. What is the formula? X by 2 root of root 3 into, in place of x we have x minus 4 by 3 by 2, x by 2 root of this value, write it as it is 5 by 3 square minus x minus 4 by 3 square, x by 2 root of, then a square minus x square, that will be a square by 2 sin inverse x by a, so plus a square by 2, that will be 25 by 9 by 2, that is 25 by 18 sin inverse of x by a, that is x minus 4 by 3 divided by a is 5 by 3 plus constant of integration. Then this will be final answer. After simplifying, we can write this. Now we can see the solution. So what is the first step? Try to take this minus 3 outside. Minus will be inside root. We can take root 3 outside this. So minus 3 times of, write the remaining factor and try to express this in perfect square term. That will be x square minus 8 by, that means we will get divided by 2 means 4 by 3x, x minus 4 by 3 whole square minus of 25 by 9, where this 3 will go outside the square root, that will be root 3 into 5 by 3 square minus x minus 4 by 3 square. Now use the formula. This is of the form a square minus x square. Answer is x by 2, where x is this part, so write that part as it is, x by 2 square root of plus a square by 2 sin inverse x by a. So answer will be x minus 4 by 3 by 2 square root of, write it as it is, plus a square by 2 sin inverse of x by a. In place of x, whatever is there, this is a linear term, so we can write it as it is, divided by a. That is it. So simplify and write final. That's it. Easy questions. Questions could seem lengthy, but it is actually very easy. We have to remember the formulas and don't make any careless mistake while solving. That is what you need to remember in this. Right now. Next is, okay, this is the simplified value. Next is integration by partial fractions. Integration by partial fractions. Okay. These are some of the formats in which we are forming partial fraction. Px plus q divided by x minus a into x minus b. Always remember, when we are using partial fraction, the term in the denominator should have a higher degree than the term in the numerator. And this is applicable for rational functions. We should not have square root of x square terms like that. It should be always a rational function. Rational means both numerator and denominator are polynomials. So you already know what is a polynomial, and always remember degree of denominator should be greater than degree of numerator. If it is not like that, then we have to use division and first try to simplify this expression. Then we will write divisor, we will divide means we will get quotient plus divisor by remainder. So remainder by divisor. So we will get this value as px plus q by x minus a. Here when we observe this, degree of numerator is 1, denominator is 2. Then we have to use this type of splitting. That will be a by x minus a, write the first factor, plus b by x minus b. When we have linear factors, we will always split it like this, a by x minus a plus b by x minus b. Next, px plus q by x minus a whole square. That will be again a by x minus a. Here as the term is repeating, we will have b by x minus a whole square. We have to repeat the factor again. So it will be x minus a by x minus a plus b by x minus a whole square. Next, p square x plus px square plus qx plus r. Degree of numerator is 2, denominator 3. Again, non-repeating linear factors. That means we will write this as a by x minus a, b by x minus b, c by x minus c. A by x minus a, b by x minus b, and c by x minus c. This is how we will factorize. Next one is, again, degree of denominator is 3 and numerator is 2. So how do we split this? Here one factor gets repeated. So again we will use the same procedure. A by x minus a, b by x minus a whole square. Whatever factor is repeating, we will repeat that factor again. So it will be like this, plus c by x minus b. This is non-repeating, so we'll write this as like how we write normally. Next one is, again, degree of numerator is 2, denominator is 3, but this factor cannot be factorized. When we already know how to factorize the quadratic term, quadratic expression, but sometimes if the quadratic expression cannot be factorized, then we will use this method to split. What is that? We will write a by x minus a plus, this term cannot be factorized. That means this will always, when we split this term always has degree 2 in the denominator. Therefore, when you divide with some number, then obviously the remainder will have lesser power than the power in which we are dividing. So that means this term will be linear. When you observe this, when you have a linear term, here in numerator we will have constant. Here again this is a linear term, in numerator we have constant. Even though this term is repeating, again we can express this in linear term now. So that is what we need to consider. As this is a linear term in denominator, in numerator we will have constant term. Remainder will be 1 power lesser than that, at least 1 power lesser than that. Similarly, here power 1, that means in numerator we will have 0, that is a, b, c, only constants. Again here power is 1, so we will have constants a, b, c. Here power is 2, degree of denominator, here in this term we can't split further, factorize further. So that means here degree is 2 for this factor. So that means even you find the remainder, it will have a degree of at least 1. That's why we are writing this as bx plus c. That is what you need to remember, as this cannot be further factorized. If you can factorize, then first we should factorize that and then use this substitution. Now after splitting this into this type of partial fraction, we will see how to solve these questions. With some examples we can learn this. First question is 1 by 6x square minus 5x plus 1. We will try to simplify this first. Try to factorize this and solve. Now what are the two numbers? Here we can write this as 6x square minus 5x plus 1 can be written as product of numbers is 6, sum is minus 5. That means we can factorize this as, split this middle term as 3x minus 2x plus 1, where sum is minus 5, product is minus 3 into minus 2, 6. So this can be further written as 3x is common into 2x minus 1 minus of 1 into 2x minus 1, 2x minus 1. So what are the factors? 3x minus 1, 3x minus 1 into 2x minus 1. These are the two factors, 3x minus 1 into 2x minus 1. Okay, now what we need to do? Integral will become integral of dx by 3x minus 1 into 2x minus 1. Okay, now this can be further written as integral of a by 3x minus 1 plus b by 3x 2x minus 1. Now how to split this? We can write this as 1 by 3x minus 1 as 1 by 3x minus 1 into 2x minus 1 as, how do we split this? This term is split as, here factors are non-repeating and linear. Sorry, a by 3x minus 1 plus b by 2x minus 1. This is how we should split this. where we can further write this as a into 3x 2x minus 1 plus b into 3x minus 1 divided by 3x minus 1 into 2x minus 1. 3x minus 1 into 2x minus 1. Okay. Now we have to find the value of a and b. How to find that? Equate coefficients on both sides. This is 1 by this denominator. Here denominator is same. That means we can equate numerator. So we will get a into 2x minus 1. A into 2x minus 1 plus b into 3x minus 1. A into 2x minus 1 plus b into 3x minus 1 equal to 1. Now how to simplify this? A into 2x minus 1 plus b into 3x minus 1 equal to 1. Now we can write this as equate, substitute some value of x and then find a and b. If we substitute x equal to 1 by 2, then this value will become 1 minus 1 is 0. That means a term will vanish and the next term will be 3 by 2 minus 1 b into 3 by 2 minus 1. 3 by 2 minus 1 equal to 1. Now 3 by 2 minus 1 is 1 by 2. So b into 1 by 2 is 1. That means b is equal to 2. Similarly, substitute x equal to 1 by 3. X equal to 1 by 3. Then this term will get vanished and we will have 2 by 3 minus 1. A into 2 by 3 minus 1 equal to 1. 2 by 3 minus 1 is minus 1 by 3, which means a will be minus 3. So now we got a and b values. Now what will be the integral? Integral will become integral of a by 3x minus 1, that is minus 3 by 3x minus 1 plus b by, b is 2, b by 2x minus 1, 2x minus 1 dx. Now what is the value of this? This will be minus 3 times of 1 by x, different in integration is log x. So this will be log of mod 3x minus 1. Now again we have to divide by this coefficient, that will be divided by 3 plus 2 into, again it will be log of modulus 2x minus 1 divided by 2, 2x minus 1 divided by 2 plus c. So that is equal to log of modulus 2x minus 1 divided by 3x minus 1, as log a minus log b is log a by b. So this will be log of 2x minus 1 divided by 3x minus 1 plus c. This will be the answer. That is how we should solve these questions. I hope this is clear, students. We will see few more problems related to partial fraction. Okay. Now first what we need to do, try to split this into factors, and if we cannot fit the split into factors, then use this other method what we have in the, similarly based on how we split, we should write the partial fractions terms. Then first we will write this, then I is equal to integral dx by, where this value, if I have to find a and b, split accordingly based on the partial fraction table that is given before. Then find the coefficient of a and b by substituting some value of x. You can substitute any value for x. You can also substitute 0, 1. But if you substitute any other value other than this, we will have two variables and two equations. We have to solve that to find a and b. Depending on whichever is comfortable for you, you can use that. Right? So this is how we should solve this problem. Then after finding a and b, what is the value of integral? Then this will be converted into standard form. It is of the form dx by x. We already know the integration, that is log mod x. Now we will see the solution first. First step is to split this in terms of two terms, where we already know some constant into dx by x term is log of answer. So that is why we are using partial fraction. and this is x equal to 1 by 3. If you substitute, then we will get the a value, that is minus 3, and similarly b value, that is 2. Then this term will become integral of this minus 3 by 3x minus 1 plus 2 by 2x minus 1. Now we can integrate this. What is the integral of this? Minus 3 times of this value integration is log of x, that is log of 3x minus 1, and we should divide by the coefficient. Similarly for the other. So final answer is log of 2x minus 1 by 3x minus 1 plus c. Okay, next question. X minus 1 by x minus 2 into x minus 3. Now again by observation we can write this as, here degree of numerator is 1, denominator is 2. So that means we can use partial fraction. That is the first observation we should make. Degree of numerator is 1, denominator is 2. So we can write this as, how to split this? We can write this as integral of a by x minus 2 plus b by x minus 3. So we will write this as, first x minus 1 divided by x minus 2 into x minus 3 can be written as some constant a divided by x minus 2 plus b by x minus 3. Now this is equal to a into x minus 3 plus b into x minus 2 divided by x minus 2 into x minus 3, x minus 2 into x minus 3. That means we can equate both sides, then we will get x minus 1 is equal to a into x minus 3, a into x minus 3 plus b into x minus 2. Okay, next what we need to do? Substitute some value for a and b, sorry x equal to 3 means, here left hand side will be 3 minus 1, that is 2, equal to this a term will get 0. Here b will be 3 minus 2 is 1, b is equal to 2. Similarly x equal to, we can substitute 2 now. X equal to 2 means what is the value of a? 2 minus 2 will become 0. Here 2 minus 1 is 1, that is equal to 2 minus 3 is minus 1. So a will be minus 1. So now we got a and b values. So what is the integral now? Integral will become integral of a by x minus 2, that is a is minus 1 divided by x minus 2 plus b by plus 2 by x minus 3 dx. Now what is the value of integral? This is equal to, integral will be minus log of modulus x minus 2 plus 2 times log of modulus x minus 3 plus constant. Now this is x minus 3 whole square, so we can write this as log of modulus x minus 3 whole square divided by x minus 2 plus constant of integration. This is how we should solve, students. Clear now how to do? Yes, procedure is very simple. First we need to know how to write the partial fraction, how to write this partial fraction, and then use the appropriate method to solve. Find the coefficient a and b and then substitute in the integral. It will automatically convert to standard forms. So first we will write this term as a by x minus 2 plus b by x minus 3 based on the partial fraction table we have seen before. So then what we will do? This term will become, equate the left hand and right hand side, denominator will get cancelled, x minus 1 is equal to a into x minus 3 plus b into x minus 2. Then substitute some value for x. Then we will get a value as well as b value. Then what we need to do? Write this in partial fraction terms and integrate. So this is equal to 2 log x minus 3 minus log x minus 2. You can write answer like this or write the answer in a single log also. If you write that like that, then it will be, this will go to the power, that will be x minus 3 whole square divided by x minus 2. Both are correct. Next question is integral of 7x minus 4 by x minus 1 whole square into x plus 2. Now we will first find how to find the values of a, b. How to first write this in terms of partial fraction? This term can be written as 7x minus 4 divided by x minus 1 whole square into x plus 2 can be written as first a divided by x minus 1. Here factor is repeating, that means we will write this as plus b divided by x minus 1 whole square plus c divided by x minus 2. Now take LCM, which means we will get, finally this denominator will get cancelled. When we take LCM, we will get 7x minus 4 is equal to a into x minus 1 into x minus 2 plus b into x minus 2 plus c into x minus 1 whole square. X minus 1 whole square. Now we will substitute some values for x. Let's substitute x equal to 1. That means 1 minus 1. A term will get 0. C also will get 0. That means when we substitute 1, here we will get 1 minus 2, that is minus b. So minus b is equal to, here we will get 7 minus 4 is 3. So b will be minus 3. Right. Next we will substitute another value. Say we will substitute 2. X equal to 2. Then here we will get 2 minus 2 will get 0. Here also it will get 0. 2 minus 1 is 1. 1 square is 1. So we will get c in the right hand side. That is equal to, here we will get 7 into 2 is 14. Minus 4 is 10. C equal to 10. Next what we need to do? Substitute some other value. Here we can't substitute any value other than this. So the term will become 0. So then what we will do is substitute x equal to 0. Substitute any number. That means we will get minus 4 is equal to 0 minus 1 is minus 1 into minus 2. That will be 2 times a. 2 times a. Again 0 minus 2 is minus 2b. Minus 2b. Here 0 minus 1 is minus. So it will be plus c. Plus c. Now substitute the values. Which means we will get 2a is equal to minus 4 plus 2b, that is minus 6. Minus c, that is minus 10. Correct? What are you doing? Substitute b and c values. We have already found that minus 2b is 6 plus 10 is 16. That will go to the left hand side. Then we will get minus 6 minus 10. So answer is, this is minus 20. Which means a is equal to minus 10. Okay. Now we got a, b and c values. So this integral will become integral of, first term is a by x minus 1, a is minus 10 by x minus 1 plus b by, what is b? Minus 3 by x minus 1 whole square, x minus 1 whole square plus c by, c is 10, so plus 10 by x minus 2 dx. Now we can integrate this easily. What is integration of first one? This is equal to minus 10 into log of modulus x minus 1. Next term is dx by x square. That will be dx by x square. X power minus 2. That will be x power minus 1 by minus 1. So we will get minus 3 times of x minus 1 power minus 1 divided by minus 1 plus 10 into, this will be log of modulus x minus 2 plus c. So this is the final answer. So what we get finally, 10 times log of modulus x minus 2 by x minus 1, as this is plus minus log a minus log b is log a by b, plus 3 by x minus 1 plus c. This is the final answer. I hope this is clear, students, how to solve this type of problems. Now we'll see the solution. First we have to write this in terms of partial fraction, and always remember we have to first check if the degree of denominator is greater than degree of numerator or not. Only then apply this partial fraction. Otherwise it will be wrong. Right? So after splitting into partial fraction, find the coefficient a, b and c by substituting some x values. Then you will get a, b, c values, and finally write this in terms of partial fraction. Final answer comes out to be this. Next is 2x plus 3 by x plus 2 into x square plus 4. First we will see how to write this in terms of partial fraction first. We will write this as, here again degree of numerator is 1, denominator is 3, so we can apply partial fraction. And how to write this in terms of partial fraction? 2x plus 3 is a by x plus 2 plus, this is non-repeating and we can't factorize further. That means we will write this quadratic as bx plus c by x square plus 4. So how to write this in terms of partial fraction? A by x plus 2 plus bx plus c by x square plus 4, and then further simplify this. So a into cross multiply x square plus 4 plus bx plus c into x plus 2 divided by denominator while taking LCM. Then what we will have? These two will get divided. Then we can equate the numerator and find the value of a, b and c. Take some value for x and y, x value, substitute some value for x and find a, b and c. So we get a value is minus 1 by 8, and again substitute some value for b, x value, and find b value. That comes out to be 1 by 8. Then after that, substitute both and find c value, because we have three coefficients now. What are they? A by some number plus bx plus c by x square plus 4. That means we have to find three coefficients a, b and c. So we have to take three substitutions. Substitute x value 3 times different values and find a, b and c. Procedure is same for all types of partial fraction. First we have to write in appropriate form and then find the value of a, b and c and then substitute back. Now after getting a, b and c, we will write this in terms of appropriate form. Then we will get minus 1 by 8 into this plus 8x plus 14 by this value. Then what we need to do? Write this in terms of form. Integrate this on both sides. Now first integration is easy, that is minus 1 by 8 is constant, dx by x form, that is log of x plus 2. Next term is 1 by 8 into, we can split this further into two integrals, that will be x by x square plus 4 plus 14 by x square plus 4. That will be, here when we substitute x by x square plus 4, differentiation of x square, denominator is 2x, so we can multiply and divide by 2 and this will become log of x square plus 4. Here we already have 1 by x square plus a square, dx by x square plus a square. Answer is 1 by a tan inverse x by a. So this is a standard integrable form. So that means what is the answer? Minus 1 by 8 log of this value plus 1 by 16 into 2x is a differentiation of x square plus 4. So answer will be dx by x form, dt by t. So answer is log t, that is log of x square plus 4 plus 7 by 4 into 1 by 2 into this tan inverse x by a, that is x by 2. So simplify and write the final answer. Next question is integral of dx by x cube plus 1. Okay sir, until now we can split this easily, and here we have cubic term. Can we factorize this? A cube plus b cube. What is the formula for a cube plus b cube? A plus b into a square minus ab plus b square. So we can factorize this further. What are the factors? This will be x plus 1 a plus b into a square, that is x square, minus ab, that is minus x, plus b square, that is 1. So these are the factors. Can we factorize this further? We can't. because this is non-factorizable. So this is a quadratic which cannot be factorized further. So this is a partial fraction in terms of degree of numerator is 0, denominator is 3. So we can apply partial fraction and we can write this as a by x plus 1 plus bx plus c by x square minus x plus 1. Similar to previous problem. So a by x plus 1 plus bx plus c by x square minus x plus 1. Now again substitute some values for x and try to simplify. First take LCM and write numerator and then simplify this by making some substitution. Find the value of a, b and c. Find the value of a, b and c. So a is 1 by 3. Again another substitution. We can substitute any value for x and try to find all the values. Then we will get 3 equations, 3 unknowns and solve. So finally we get a, b and c values and the partial fraction. Again we substitute in the partial fraction. We will get the integral of a is 1 by 3 into x plus 1 plus b is, here b is minus 1 by 3, that is minus 1 by 3. This term is as it is. Now try to simplify this. C is 2 by 3. So we can write this as common and again we have to split this into 2 integrals because there is no direct formula for this. We hadn't learned how to integrate this type of function. So we try to split this into 2 separate integrals just like how we did in previous question. So here this is 1 by 3 integral of dx by x plus 1, that is log. Here we will have x by this term, that is again we have to differentiate this, split this. What is the differentiation of this? 2x minus 1. In numerator we have x minus 2. So what we need to do? Try to bring 2x minus 1 in the numerator. That will be 2x minus 1 minus 3. When we multiply and divide by 2, we will have 2x. So split this into 2 separate integrals after that. This denominator differentiation should be in numerator. That is our purpose. Then we can easily split. This x term will also get vanished and then we will have constant by x square term. That we can integrate easily. We already know how to do that. So first integration is actually very easy. Second will be make the denominator differentiation in numerator. That will be 2x minus 1. So make that in numerator by appropriate multiplication and division by some constants. Again plus this will be 1 by 2. 3 by 6 is 1 by 2. 1 by. Now what we will do is try to factorize this. Make this in form of perfect square. Just like how we did in previous standard integrable forms. What we need to do? This can be written as x minus 1 by 2 whole square. Then we have to subtract 1 by 4. That will be 3 by 4. Again it will convert into standard integrable forms. So 1 by 3 times of this. We can write log of x plus 1. Then this different integration will be integral log. This will be log x square minus x plus 1. Then plus 1 by 2 of, now this is of the form dx by x square plus a square. Formula is 1 by a tan inverse x by a. One by 3 log of minus, again this will be in the form of denominator differentiation by denominator, that is log of denominator, plus next term will be 1 by a tan inverse x by a. Easy. Questions will be lengthy in this, but still we can solve easily. As long as you don't commit any careless mistake, that is the only consideration we should make in this. Otherwise it is very, very easy to solve. Okay, with this we will complete this session. We will start the next session afterwards. And always keep learning and keep growing, students. Success is yours line by line. Endigu endendigu namma tapasya.